So on this lovely day, we're going to continue on a little bit. Granted, we just finished that other one, but we are going to look at the next section today and on Wednesday. So let's work through each of these problems here. And just someone call out, what is the square root of 36? There we go. So just 6. It just simplifies to 6. All right, this one over here, we have to do two things. First, we're going to take care of the exponent. The exponent's got to go in this case, to each base, like so. And this exponent also has to go to each base, to that one and to that one. So you don't have to write this second step, but you're welcome to. So this one is 3 squared a squared times 2 cubed a cubed. You could have done the multiplication, but if you need to see a placeholder to see what happens, then you're welcome to do that. Okay, now we're going to apply a couple things at the same time. Notice I'm going to take this right here, 3 cubed times 3 squared times 2 cubed. 3 squared is 9, 2 cubed is 8, so 9 times 8 is 72. So all of that becomes 72. Now for the a's, remember with the a's, this is a product of powers, so we add the exponents. A to the 5th, and we're done. What I like about C is that C, things drop out pretty quickly, one thing at a time. So I'm going to deal with the coefficients first. Coefficients first, the 4 and the 16. Notice both of these can be reduced by 4, so this becomes a 1, and this becomes a 4. Now let's take care of the a's. This a is a power of 1, so it's almost as if it gets pulled up. All of these a's go away, and only one of those go away. So now I'm left with an a to the 1 in the numerator. What about the b's? All of these b's come down and add to that b down there. So it's b to the 7th downstairs, because the negative exponent says drop the base down. And this base, the c, comes all the way up. That comes all the way up to make that into an 8, because now you add 5 more to that cube. Now the part of cleaning up comes about. So let's see what's left on top. I have only an a right here and a c8. So a times c to the 8th power. And down below in the denominator, I have a 4 and a b7. So 4 times b to the 7th power. And there we go. Whew. This last one is just about square roots. Just about square roots. So the square root of 144 is 12. The square root of b squared is just b. And this one is a little bit more thought maybe. The square root of c to the 4th is actually c squared. Now there's more to it than just that, but today we'll leave it, or for now we'll leave this as that. Today what we're going to be focusing on is we're going to spend more time with this type of problem, where we have square roots or third roots, cube roots, or fourth roots. So let's look at some vocabulario first, down here. So we'll start inside the right box there, where it says this little n on the outside, the square root symbol, and the a inside. All right. So each piece. This symbol is often read radical, or it is the radical. Inside is called the radicand. Whatever's inside, even if it's more than one, like it could be a complete parentheses, 2x plus 3. If it's inside that symbol, the radical symbol, or the root symbol, excuse me, inside the root symbol, we call it the radicand. And this number on the outside is called the index. The index. Now, you might have noticed on your iOS device, iOS actually says this, and they put a little 2 out there. Because iOS says, oh, make sure you know that it's the square root. It's the square root. But most of the time, if you're talking about square root, you just write this symbol, and that's it. So, but whatever root we're dealing with, that's what the n represents. So, let's look over here and see about how to reword and see the relationship between the 4, the 2, and whatever we get here. Obviously, 4 squared is 16. As a result of that, 4, let me color code this here. The 4 is the square root of 16. Of 16. 4 is the square root of 16. Now, by the way, I'm not quoting this right here. I'm not quoting it. If I were to read this math problem, it says this: 4 squared is 16. 4 squared is 16. But how does 4 relate to 16? 4 is the square root of 16. So that's how it relates there. So, same thing here. 4 cubed is 64. So what is 4's relationship to 64? 4's relationship to 64 is 4 is the cube root of 64. So the base 4 has a relationship to 64. What is it? It is the cube root. Because 4 cubed is 64, 4 is the cube root of 64. 4 to the 4th power is 256. So that means 4 is the 4th root. And now after a while, we stop using special words and we just say the numberth. The 4th root of 256. Another way of writing it, and I'll write it out on the side right here, it looks like this. 256 is on the inside. The 4 is the index, and all of that equals 4. 4 is the 4th root of 256. 4 is the 4th root of 256. Why is it the 4th root? Because 4 to the 4th power is 256. And so forth, so on and so forth. So, 4 is the 5th root of 1024 there. I think that's right, 1024. And so we would repeat this same pattern here. And another way to write it would be like this. Way over here, I'll write that. Where we say, and notice this index has to be a small number. It's like an exponent hanging out above the check part. The 5th root of 1024 is 4. Or another way of saying it, 4 is the 5th root of 10 to the 24. So let's talk about key concepts here and also show you some caveats or how to manage certain symbols and words. Okay, so I'll read through this here. It says this: if a to the nth power equals b, with a and b being real numbers and n is a positive integer, then a is the nth root of b. And by the way, that's pretty much what we just said up there. A is the nth root of b. So a to the n equals b, so a is the nth root of b. Like I said, it's what we said already above. So, how to manage with certain roots here. If n, now again, when I'm saying n is my exponent. When the exponent is an odd number, and again, odd can be 1 or 3 or 5, etc. If n is an odd number, then there is one real nth root. And this is how we write it. So let me just write an example for example here. What is the third root of negative 27? Well, the answer is negative 3. Why? Because negative 3 times negative 3 times negative 3, that's cubed, is equal to negative 27. So there's only one of those. Only one. And the answer here is negative 3. Or I could alternatively say something like this. What is the third root of 8? The answer is just positive 2. Why? Because 2 cubed is 8. While we're here, let's look at the bottom one there. So notice there's different rules we're looking at here. This is one rule here. This is a second rule here. The only nth root of 0 is 0. So 0, the fifth root of 0 is 0. The sixth root of 0 is 0. Whatever root you put, whatever index number you put, you always get 0. Except maybe 0? Maybe even 0 as well. Oh, n can't be 0. N's a positive integer. So, all right. Now, what happens if n is even? What happens when n is even? For example, what happens when I say the fourth root of 64 like this? Or, we'll get to that in a second. Okay. If b is positive, so like this. So we have a to the n equals b. So let me just throw some numbers down here. Let's say I'm looking for the fourth root, and b is some number 64, okay? So because b is positive right there, and because this is even right there, when I take the fourth root, there are two real nth roots. Two real roots. One positive and one negative. One positive and one negative. So, in other words, a is going to be positive 4 and negative 4. Or you could say plus or minus 4. Where did I get that? Because the fourth root of 64 is 4, but because of the even, I have a positive version and a negative version. Let me just show you that it does work. For example, if I plug 4 back into here, I get 4 to the fourth is 64. But what happens when I plug in a negative? What happens there? Negative 4 to the positive fourth is also 64. I made a quick error there. Let me change that to a 64, not 6 to the fourth. Like so. So in summary, when dealing with an even exponent, don't forget the plus or minus. However, I do want to point out to you, we often deal with the principal root, just the positive most of the time. So we'll walk through it in just a second down below. When do I deal with only the positive, and when do I do both? Okay. Lastly, if b is negative, let's point out here, b is negative here, and I have an even there, then we get no real solutions, no real. So a to the n equals some negative number, like negative 64, and I wanted to know what the fourth root of that was. This would be no real. We could find the real, but we also don't want to overcomplicate I, because the square root of I gets even more complicated. So whenever this is even, but over here is negative, we just stop and say no real. It won't go further. All right. Now what's nice is here, when we're evaluating these, we can use our calculators to speed things up. So we're going to find all the real roots of each number. Notice, in this case, this is the square root, which is even. It's even. When you have even, you have to have plus or minus as your result. Okay? So what is the square root of 400? Well, let me maybe pull up a calculator, just in case I might want to do that. So in my calculator, I put the square root of 400, but don't forget I have a positive answer and a negative answer. When it's asking me to find the roots, notice there's no square root symbol. There's no square root symbol. So it's asking you essentially to solve this problem. You don't have to write this, but this is what's happening in the head. What number squared is 400? What number squared is 400? That's what this question right here is asking. So you say, oh, positive 200 or positive 20 or negative 20. Okay? Now what about this one? Because we have a negative right here, the answer is no real. No real roots. And we can stop there. All right, please attack, kill, destroy 3 and 4, and feel free to use the calculator as well. This one here becomes plus or minus 100. Again, we have to put the plus or minus because we're dealing with an even root. And because we have a positive number, the 10,000, we know we're going to have 2 options. How about number 4? But again, we have to say the plus or minus 0.25 or plus or minus 1/4. That works as well. Okay. Let's do the cube roots here. So let's look at this, number 5. Number 5 says find all the real cube roots. Why is that important? Well, cube is odd. Cube is odd. So there is no, because it's an odd root, there is no plus minus. It's just whatever you see. This one has a hidden positive. So my end result is positive, whatever. This one has a negative. So my end result is a negative something. This one, end result, is a positive something. So I just plug that into my calculator. What is the cube root of 216? Now, how do you do cube root 216 in the calculator? So I punch that into my calculator. And because the 216 is positive, my end result is positive as well. The cube root of 6 is 16, or 216. Notice, this one starts out with a negative, so this one's going to end up with a negative. And I just punch into my calculator the cube root, end result, negative 7. All right, see what you can do for 7 and 8. Because I'm dealing with an even number on the root, this negative comes down, and the other part can come from the calculator, like so. What's nice about this one is we find the cube root of the top and the cube root of the bottom and keep the positive here. The cube root of 1,000 is 10. The cube root of 27 is 3. And the answer is a positive 10/3 there. Positive 10/3. When we look at the next one, find all the real fourth roots, the first thing we recognize is that fourth is even. So that means I'm going to have a plus or minus situation sometimes. And notice here with the negative, because this is negative right here, then I'm going to say, well, this doesn't even have a root, a real root. So here we say no real roots. Because of that negative, no real roots. But this one over here, number 10, it's an even, so we're going to have plus or minus, and because the value is positive here, we just take this, the fourth root of this. So how do we find a fourth root? You're going to have to pull out a calculator for that. So the answer here is plus or minus 4. So what about the other two, 11 and 12? Go ahead and attack that real quick. 0.1 plus or minus 0.1. Remember, because I'm looking for an even root, anytime I get a real solution, all of them have to be plus or minus. Up here's an odd root, so I just bring the symbol down. This symbol's negative, this symbol's negative, this symbol's positive. Evens are plus or minus. Odds are what you see is what you get. And this last one here, when you find the fourth root, you get a positive and negative 5 there. because we have this symbol already there, what you do is you need to take pretty much whatever symbol is in front. That's the one that comes down. As opposed to this, right? Before we said find square root of a number, and I'll just give you 44, 144. This means, the instructions here mean what number or numbers work. So we say, oh, there's two possibilities. One possibility is x can be positive 12, and the other possibility is x is negative 12. So here are my two results. When asked the question, find the square root. Look, there's no symbol, and so we interpret it as an equation. We interpret this as an equation, okay? When we see just the symbol like this is not an equation, not an equation. So because it's not an equation, we have to treat the even stuff, we want to force the even stuff to be kind of positive when we take this root. So what does that mean? So take a moment to write this down up on the top, and it says something like this. The nth root of nth powers. So notice here, usually we say something like this. Oh, look, it's the nth root of an nth power, and you don't write this, but oh, this cancels out with this, and we're left with a, okay? Just like if I said x plus 2 minus 2, you say, oh, look, the plus 2 minus 2 drops out, you're left with x because of the inverse, and that's true. There is some truth to that inverse part, okay? These are inverses of each other. This nth root and this power of n are inverses. However, the caveat is this. We can easily just cancel those out whenever the n part is an odd, like a 3 or a 5, okay? So, for example, 3, well, let me try this. 4 cubed, the cube root of 4. Those drop out, and you're left with just 4, right? That's it. It's just that value of a, whatever it is. If a happened to be negative, like this, still, the cube root drops out, and I'm left with negative 4, okay? Whatever value of a it is, that's what comes out. Under the condition that the n is an odd number. But when n is even, we have to force the positive to come out. What do I mean by that? So if I said this, what is the fourth root of negative 2 to the fourth power? Okay? It is not this. Don't write this down. We don't just cancel it out and say negative 2. What we do is say the absolute value of 2. So the answer is actually 2. Okay? So if n is even, we need absolute value bars around the letters. Around the letters. We need absolute value bars around the letters. Okay. So let's try that here. Okay. In this case, I don't really need absolute values because I know 144 and I can write 12. 12 is positive, and that's it. That's my answer. But Swenson, aren't we supposed to do plus or minus? No, because this is not an equation. We only bring down just the 12. On the previous over here, if it were the equation, it's a plus or a minus. And let me just clean that up so you see that it's a 12. Okay. Now this one here. This part is 5. And then I bring this guy down. Negative 5. Notice the negative. Notice that the negative is not part of the root. The negative is outside. It says the opposite of the square root of 25. Oh, the square root of 25 is 5, so the opposite is negative 5. The opposite of the square root of 25. So this becomes 5. This is negative. Again, this negative has nothing to do with what's inside. All right. Notice with 15. With 15, if the negative's on the inside and we have an even right here, see the even, it's a 2. This is no real. What about number 19 there? Because this is even, the negative means no real root. This is odd. That's odd. So down here is just negative 3. Where did that come from? The cube root of 27, and then have that negative come with it. All right, the last thing I want to show you is just how to use and when to use these absolute values. When to use these absolute values. Again, this is not an equation because there's no equal sign, and it didn't say for us to find the roots. It just says, essentially, we're simplifying the symbol that we see here. So each component we just simplify here. The square root of 81 is 9. There's no plus or minus, okay? Do not put plus or minus here because we're not solving an equation. Just bring it down. Now here, how do we manage letters when we're taking roots? Well, it's as simple as this, actually. There's a hidden 2 right there. So you take this 4 and you divide it by the 2. So I get 2. So that's what goes down. Like so. But in the end, because of this even right here, we have to do absolute value around the letters. Absolute value around the letters. Granted, I understand it sounds a little bit complicated, but hopefully with some practice we'll go quickly. So notice this one here, number 22. The square root of this is 11. Again, no plus or minus. For this guy, just divide this by 2. Divide it by 2. So we get y to the 5th and put absolute values around that y. Why do I put the absolute value? Because this is even. When there's even, don't forget the absolute value. When the index is even, don't forget the absolute value. Number 25. This is odd, so you don't need absolute value at all. Because this is odd, no absolute value needed. Okay? Because that's odd. So I just find what's the 5th root of 243. So I might need to use my calculator to find the 5th root of 243. So that part here becomes 3. Now, for this guy, we take the 5, this 5, divide it by that 5. So it's just a 1. So we're left with just x. And for this one, take the 15, divide it by the 5 to get a 3. So we end up with y cubed. No absolute value. Why? Because this index is odd. The index is odd. By the way, if there were a negative on the inside, I would have brought it down. If there were a negative on the inside, I would have brought it down. Because odd index can have negative or positive on the inside, which means the result is negative or positive. It's the even stuff we have to be aware of. The even stuff can't have a negative to get a real root. And the even stuff needs to be, the letters have to be absolute valued. Why are we doing that? That's because y could be a negative number in theory. Maybe y originally is negative 6. If it really is negative 6, I don't want to carry the negative down with me because of the even. So in the end, I have to clean it up. Just make sure everything is absolute valued. So this part here becomes 5. Notice, because I have an odd index, there's no bars needed. I'm just bringing down this symbol right here. This symbol's positive, so it's positive there. And the x component just takes the 9, divides by the 3, and we're done. That's it. There's no absolute values needed because the index is odd. But here, the index is even. So the 25 comes down. We clearly see the 25 comes down as a 5. But what happens to this? Well, I take the 4, divide it by the 2 to get this. X plus 2 squared. But don't forget, put the absolute value bars there. Although